Hello, my name is Alessia, and together with my colleague Eva, we want to present you our project about the microplastic in the Black Sea waters. We are from Ovidus High School, Constanța, Romania. The issue of plastic waste is a topic that has been intensively researched and studied lately and is the subject of concern of international organizations and governments that are trying to develop legislation to limit their impact on natural ecosystems and human health. Recently, the focus on waste management has been on microplastics, a very little research field to date. That is why we set out to study the problem of microplastic in the waters of the Black Sea and coastal ecosystems. Classification of plastic from marine wastes. It can be done by dimensions, and microplastic is 1 micrometer to 5 millimeters, and it can be done by the type of fragment. And some examples can be foam, rubber, microgranules, fiber, filaments, and this project objectives in the identification of microplastic pollution sources in the Black Sea area, performing a working procedure for determining the microplastic content, proposing an alternative method of producing a material with properties similar to plastics. For the microplastic analysis, we needed glass containers for collecting the samples, physical chemical analysis kits, petri dishes and glass slides, optical microscope, stereo microscope, and 2 millimeters diameter metal sieves, 1.5 micrometer filter paper, graduated cylinder, pipettes, berzelius cups, tweezers, spatulate needle. For the bioplastic production, we needed graduated cylinder, pipettes, berzelius cups, sodium hydroxide, hydrochloric acid, distilled water, industrial starch, metal filters, glue and chisel, and biological material, potatoes, marine macrophyte algae. For the water samples, we needed to collect 100 milliliters water samples, which we filtered using a 0.2 millimeters filter, and this mixture was treated with 10% potassium hydroxide and 40% distilled water solution. We kept the mixture for 24 hours and isolated the microplastic from the supernatant, transferred to a petri dish and dried it for 24 hours. After we observed it under stereo microscope and light microscope and photographed the microplastic. For the sediment samples, we needed to collect 100 grams sediment samples from the waterline and on transect lines on the beach. We transfer it to 40 milliliters Berzelius beakers and treat it with 28 per ml sodium chloride solution to increase solution's density and shake it. We isolated the microplastic from the supernatant and treated with 50% hydrochloric acid to destroy the remaining organic matter. Transferred to a petri dish and dried it for 48 hours. We observed it under a stereo microscope and an optical microscope and photographed the microplastic. For microscope observation, we needed to divide the petri dish according to the diagram below and calculate the dimensions of the identified microplastic using the formula lens diameter on objective or ocular. Some sources of errors can be the contamination of samples with microplastic from tools, equipment used, fibers from clothing or sample handling, and confusion with natural materials like shell fragments, charcoal, wood. There is a map of the collecting stations. And in this diagram, you can see that Reina is one of the most polluted with microplastic. And here the biggest percentage was of microgranules. In this diagram, you can see the percentage in which the microplastic was founded. And again, microgranules and fragments were the most abundant, while the foam and rubber the less abundant. And here you can see that the 20 meters waterfront transect line was again the most polluted, and this was for the Park Station. And in this table, you can see the types of microgranules found it in each station, and the total was of 214 elements of microplastic. And again, another diagram in which you can see the percentage of each type of microplastic, and again, the most abundant were the microgranules. This is a sum up diagram for the transect lines, and we saw that the most polluted one was Zoom, especially in, I think, all the lines.
Conclusions: 14 water samples and 56 sediment samples from the water line at the distances of 10 meters, 20 meters, 30 meters from the water line were taken at eight stations about 500 meters apart on 3 sampling days. In the water samples, the highest percentage is represented by microgranules and the lowest by foam and rubber. The station with the highest frequency of microplastic was rain and pitch. We correlate this with the geomorphological characteristics of the shoreline in that area. Semi-enclosed bay with reduced water circulation. In 65% of the samples, those taken at a distance of 20 meters from the water line, were the most abundant in microplastic. Conditions determined by the abiotic factors did not significantly influence the distribution of microplastic in the samples taken. For the sediment samples, 2014 microplastic elements were found, the most on Zoom Beach, which is a semi-enclosed area, and the least on Azure Beach, a narrower beach with open shore. Microgranules accounted for about 30% of the microplastic found and have the highest abundance, and foam and rubber the lowest abundance of 3%. 20 mussels with a total biomass of 68 grams were analyzed, and over 150 microplastic particles were identified, most of them attached to viscous filaments and in the gills. The average size of microplastic particles was about 0.05 to 2.5 millimeters. We did not identify a particular color weight of microplastic found in the sample. Solutions: by extracting starch and adding inexpensive and non-polluting substances such as sodium bicarbonate, acetic acid, and glycerin, plastics with elastic properties are obtained, which can be molded into shapes or blades. A lesser known and used resource, but one that is present on Black Sea coastal beaches almost constantly throughout the year, are the marine macrophyte algae. Although they contain less starch than the higher plants, they are found in very large quantities on the shore, often in a decomposition state, causing discomfort to tourists and locals.
After collecting and drying the algae, I boiled the material obtained, and after filtering, added sodium hydroxide, and then I compressed the material and heated it in the oven 20 minutes at 150 degrees Celsius. Bioplastic from the potato starch, we needed to fragmentate the potato, and then I let it in the water for a few minutes. I filtered it, and the starch thus obtained, I treated it with glycerin and hydrochloric acid. I heated the solution for 50 minutes, then I poured it into a petri dish. This table was is the scale 1 to 5, and we found that the microplastic, that the plastic from freshly extracted starch has a very big elasticity, and the one from industrial starch, it's a 4 elasticity, and another very elastic plastic was the one from industrial starch and algae powder. As the resistance, the same grades are kept, in which the one from freshly extracted starch and algae powder were the most resistant, and the industrial starch was a bit less resistant. But flexibility, they are all the same. And biodegradability, we saw that the one from freshly extracted starch and industrial starch and powder are the most biodegradable. And the one from industrial starch is not so ecosystem friendly. The costs were done in bronze, and we saw that even if they are more expensive, they are much friendlier with the ecosystems, while the one from industrial starch is not. The advantages of bioplastic: the reduction of fossil fuel consumption for plastic production, reduction of CO2 emissions, use of vegetable waste, vegetable oil, starch, cellulose from agriculture, food industry, especially fast food, use of potentially polluting biomass, microalgae dumped, low production cost, obtaining a biodegradable bioplastic. In these photos, you can see the microplastic in the sediments. And here are shell fragments from coarse sand. Here you can see the separation of the sediment fractions and the analysis of microplastic fragments in the mussels, especially this last image. You can see the microplastic in the filament, the business filaments. And thank you for your attention.